Okay, so now we're going to look a little bit more at some steps that were taken to solve equations. So if we look at number 3, so this is the back side of the lesson 4 notes. So Mai and Noah also solved the equation, but some of their steps have errors. Okay, so this is the same equation that was done on 4.2 by Claire and Lynn. It says find the incorrect step in each solution and explain why it is incorrect. Right? So if we take a look at what Claire and Lynn did, both Mai and Noah seem to start with the same process on the left side of their equation by looking at these two steps and combining like terms. So these two steps for both of them are actually okay. So I'm going to put a little check mark there just so because we're going to go through and kind of check what they've done each step of the way. We don't have to write out what they did. However, the practice that comes with that is really, really helpful. So we're going to anyway. So from our original down to the first step, we have combine like terms. Let me zoom in here for you. Okay, so we have combine like terms happening on that first step. Now from this step here, let's check and see what happened. Now the left side changes and so does the right side. So let's take a look and see what Mai did and determine if it's mathematically correct. So on the left-hand side, my 3 did not change, but 12x became 7x. Now, if she had divided something or multiplied something, both numbers would change. So because just the x's changed, then we know we're dealing with addition or subtraction of 5x. So we're actually looking here that she removed 5x from the left. So let's take a look and see if she did the same thing on the right side. Now, if you look here, the 5x did disappear because now I've only got 3 times 9. This is showing an error. So there is an error on this step. You cannot just start pulling out numbers out of parentheses. Okay, if we take a look at what was actually supposed to happen here, the 3 was actually supposed to distribute to the 5x and to the 9. This should be a distributive situation. So when she just eliminated this 5x, she was wrong because when I distribute, it's actually supposed to be 15x. So she should have distributed the 3. That is not 5x she's removing. She actually removed 15x and didn't even realize it. There is your error. So I want you to make a note here. Make a note of the error and put like a box around it. That's a problem. Now, if we continue on, I mean, at this point, if you were grading this, it's wrong, done, whatever. But if we continue to look and see what she did, she actually, if this part was correct, she completes everything correctly. If you look here, she multiplies 3 times 9 and gets 27. Then she removes a 3 on the left and on the right. So this step was actually correct, right? She added -3 to both sides. Then from this step to this step, she's actually correct too, because 7x becomes x, 24 becomes 24 over 7. She actually divides each side by 7. So mathematically, most of her steps are correct, but because she made an error up at the front, her answer is wrong. She's wrong because she made the mistake of just eliminating 5x here instead of distributing. So again, even though she started out good and then she ended mathematically correct, she's still technically, she's wrong. It's not 24 over 7. If we take a look back at Lynn actually completed the step correctly. If we look here, she distributed the 3 and got 15x plus 27. And if you look back at Mai, she got the 27, but it's 15x plus 27. See, it should be 15x plus 27. She did not have just 5x to remove. All right, let's take a look at Noah. Noah is also wrong. We've got to figure out where Noah went wrong. Okay. Now, with these equations, there are many, many ways to get to the correct answer. Just because a step was done that you would not have done doesn't mean it's wrong. Our job is to see, did they complete the math correctly? If they added something to one side, did they add the same thing to the other? If they multiplied or divided on one side, did they multiply or divide the same thing on the other? If they simplified, did they do the math correctly? So let's take a look at Noah. So the left side changed and the right side changed. So we've got to decide, did they do something to both sides? If you look, the left side of Noah's first step actually looks like the same thing that everybody else has done so far. If you back up to Mai, she gets 12x plus 3. Yesterday, or in the front page, Claire gets 2x plus 3. Lynn gets, 12x plus 3. So what Noah did over here by combining like terms, I'm just going to say CLT. What Noah did is actually mathematically correct over here, right? Combined these x's to get 12. If you look at the right side, though, Noah actually distributed on the right-hand side. So Noah did some simplifying on each side all at once, which is totally fine. Okay. Nothing wrong with that. So Noah just did some simplifying on each side, and that's fine. Saves a little step. If you can keep track of everything, that's okay to do. So now let's see what happened on the next step. Now, if you are struggling because you're seeing everything all at once, okay, you may want to use something to help kind of cover up what you're working on. You know, if you only want to focus in on the steps that we're looking at. Okay, so you may want to cover up everything but the 2 steps you're looking at. But on the left-hand side, my 3's don't change, but 12x becomes 27. So because everything on that side didn't change, I know we're either looking at adding something to both sides or subtracting something. Same thing on the right-hand side. everything didn't change. My 27 actually stayed the same. And if it's hard to tell what happened on the left because there's a lot going on, look at the right. 27 stayed 27. This 15x is gone. So 15x was removed from the right side. Was 15x removed on the left? If I have 12 and I remove 15, I do not get 27. If you look here, Noah added 15x on the left, and Noah subtracted 15x on the right. Another way to think about it is he added a positive 15 on the left and a negative 15 on the right. You have to do the same thing on both sides. This is where the error is at. So the error is had to add 15x to both sides. Can't add 15x to one side and subtract 15x from the other. You have to do the same thing on both sides. You have to stay equal and even. Whatever you do on the left, you have to do on the right. Unless you're simplifying. If you were simplifying something like combine like terms or distribute, that's different because it's a simplification of an expression. If I add 15x to one side and then take 15 off the other, my hangers are not balanced anymore. If I add 15 to the left, I have to add 15 to the right. However, just like my up above, from here, everything's actually mathematically correct. Noah removes 3 from the left and removes 3 from the right. Divides the left by 27, divides the right by 27. So the rest of it is actually mathematically correct, unfortunately for Noah.